All right, here's our day 3.5 video notes. My ACLab is sitting in on this, so they get to hear me give this boring video. But we're going to try and keep it short with this lesson. All right, in the last lesson, we looked at how to prove triangles are congruent. There are 5 ways we can prove that triangles are congruent. You should remember those as side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Remember, hypotenuse leg only works in right triangles. Okay? So we used those for our proofs in the last lesson. Well, in this lesson, we're going to still do proofs, but we are going to use triangle proofs to usually just take these 1 or 2 steps further and prove that other parts are congruent based on the fact that the original triangles are congruent. Okay? So we're using this concept called Cpctc, which stands for corresponding parts of congruent triangles are congruent. Again, corresponding parts of congruent triangles are congruent. That's what Cpctc stands for. So what this means is if I can understand that triangles are congruent, then I can use this as a reason to state that another pair of corresponding parts are congruent. So we're going to use Cpctc when we are asked to prove that parts, like sides or angles, are congruent. But first, you have to prove that triangles are congruent. So we're going to use this method in working on some proofs. So what you have to understand from the given information and what you're trying to prove is that you have to identify which parts that you're trying to use Cpctc for, and we can't use those angles to prove the triangles are congruent, or those sides. So in example 1, we are given this set of statements. Anytime we have a given set of information, we want to mark it on the diagram. AB is congruent to AD. AB congruent to AD. BC is congruent to CD. Now you might remember a proof kind of like this from the previous lesson. We can prove the triangles are congruent by side, side, and then side because they share side AC. Okay, so I'm going to use side, side, side to prove the triangles are congruent. Then I can prove these are congruent parts because of Cpctc. So we're going to start with our givens. Remember that in these proofs we state the givens separately. Okay, there's a pair of congruent sides. There's another pair of congruent sides from the given information. And then the last pair of congruent sides are the shared side AC. So we say AC is congruent to AC. Anytime you say a side is congruent to itself, you're using the reflexive property of congruence, POC. So that's the other pair of congruent sides. Now in the previous lesson, this 4th step would have been our final step. But here, we're going to take it a step further. So we are going to say that triangle ABC is congruent to triangle. Since I chose the order ABC, I have to choose the order ADC for the other triangle so that corresponding parts match up. And that reason is side, side, side. And since I have said the triangles are congruent, now I can say that these corresponding parts are congruent. BCA is this angle, has to be congruent to angle DCA, its corresponding angle, because of Cpctc. And that finishes our proof. Okay, and so to do our next proof, again, we want to focus on just being able to say that the triangles are congruent, and then we can say their corresponding parts. So I'm actually going to go to the end. And the very last line, you should know, always has to be what we're trying to prove. So I'm going to go ahead and fill in the end first this time. PQ will be congruent to RS, and I know my reason is going to be because of Cpctc. So right before that, I need to state that the triangles are congruent. So I'm just going to pick a corresponding order to use. I'm going to call one triangle QPS. And I know from what I'm trying to prove that PQ is congruent to SR by what I'm trying to prove. So that tells me that the other triangle needs to be called SRQ. And so I don't know exactly what reason that is until I fill out the rest of the proof. So to do that, I'm going to start with the given information. You need to remember these lines, this symbol means they are parallel. So I'm saying side PS is parallel to QR. That's going to create, most likely, alternate interior angles that are congruent. Okay, so I'm going to use some angles. I also have this given statement that angle QPS is congruent to angle SRQ. So there's another pair of congruent angles. And then remember, the reflexive property makes QS congruent to QS. So I'm probably going to use angle, angle, side. Okay? So let's start with our givens. We're going to say PS is parallel to QR because it's given. Now, there's a couple ways we could do this. Before I state the other given, I'm actually going to use this statement to get my other pair of congruent angles. Well, since these are parallel, that would make this line SQ your transversal, which creates alternate interior angles here that have to be congruent. And that comes directly from the parallel lines. So now I want to say angle PSQ is congruent to angle RQS because they are alternate interior angles. That was a theorem that we looked at back in Unit 1. Okay, so there's a pair of congruent angles. We are given another pair of congruent angles. Angle QPS is congruent to angle SRQ. There's that other given. And then, like I said, these shared side, QS, is congruent to QS because of the reflexive property, which makes the triangles congruent by angle, angle, side. Okay, I know it's angle, angle, side because the congruent sides marked here are not between the two different angle markings. And then, like I said earlier, the triangles are congruent, and so these parts are congruent because of Cpctc. Okay, and that leads us to example 3. We're actually going to hold off on doing that one. We'll either do that in class, or you're welcome to try this one on your own and kind of check and see how well you've done on this when we come to class. But we do want to move in to talking about some new vocabulary here. And in order to do our final proof in this example, we have to understand what inscribed and circumscribed mean. Okay, and so I've already filled these in. You are free to pause the video and copy them down if you want, but make sure you're listening to what I explain about these. To have an inscribed polygon means that the vertices of the polygon are placed on the circumference of the circle. So every vertex of this hexagon is on the circle somewhere. Now, this is an inscribed regular polygon, so all these sides are the same, so there's some unique relationships here. But this distance from the center to a vertex of that polygon is called the radius of the polygon because it's the radius of that circle that goes around the outside. Okay? From the center to a vertex of a regular polygon is understood to be the radius of the polygon. Okay? So every one of these would be a congruent radius if it's a regular polygon. So these are all congruent to each other. And if it's a regular polygon, all these sides are congruent also. Okay? Now, circumscribed is kind of just the opposite way. In inscribed, the figure is inside the circle. Circumscribed, the figure is outside of the circle. Okay, so a circumscribed polygon, as long as it's a regular polygon, has sides where the midpoint of each side of your polygon is on the circle. Or you can think of this as these sides are tangent to the circle. That's a concept we'll get into later on this year. Okay, so to be able to do this final example, we have a situation where we have a circumscribed circle, or an inscribed polygon, however you want to think of that. We say that it's an inscribed hexagon in circle P. We're supposed to prove that triangle APB, so I'm actually going to draw that in, you'll need to do the same, is congruent to triangle BPC. So I want to prove these two triangles are congruent, and in order to do that, I'm using either side, 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 angle, side, angle, side, angle, 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 side, or HL. Well, all we're given is that it's a regular hexagon inscribed in circle P. So the given information is regular hexagon A, B, C, D, E, F in circle P. All right, that's a short way of writing that. So to prove that these triangles are congruent, we want to use the easiest possible method. Well, what do we know about regular hexagons? Well, all the sides are the same. Well, there's a pair of congruent sides then. AB is congruent to BC. All right? But then we also know that each radius of your hexagon has to be congruent to each other radius. So that makes all three of those congruent. We also know that BP is a shared side, so we can specify it that way. So here's how we're going to do this proof. The next statement I make is that these sides, AB and BC, are congruent because of the definition of a regular hexagon. Okay, all the sides are congruent in a regular hexagon, so that's why those two are congruent segments. We also know that AP is congruent to PC because of the definition of a radius, which I just gave you earlier. All right? Well, there's two pairs of congruent sides. And like I said earlier, this shared side, BP, is congruent to itself by the reflexive property. There's the other pair of congruent sides. So the triangles have to be congruent by side, side, side. Okay, and that finishes this video. We will take a look at that last example, that example 3, and a couple other examples that are like these, and we will do the assignment in class.